Let A is equal to 0, 1, 0, 0. Show that AI plus B into A whole power n is equal to A power n I plus n into A power n minus 1 BA, where I is the identity matrix of order 2 and n belongs to n. So in this problem they have given a matrix, that is a 2 by 2 matrix, and they asked us to show this result. We shall show this problem by using mathematical induction. Principle of mathematical induction. Principle of mathematical induction is nothing but prove this result is true for n is equal to 1. Later I'll assume this is true for n is equal to k. Then I'll show that n is equal to k plus 1, the result is true. Then we can say this is true for all the values of n. Take the result. Now substitute. First we are going to prove this result for n is equal to 1. So substitute in this result n is equal to 1. So if I substitute ai plus ba whole power 1 is equal to a power 1 into I plus 1 into a power 1 minus 1 into BA. A into I, a power 1 is a, I plus a power 1 minus 1 is a power 0. A power 0 is nothing but 1, B into A. So what happens? AI plus BA. So the result is true. LH is equal to RHS. Therefore, the result is true for n is equal to 1. The next thing, we have to assume this result is true for n is equal to k. Now I have assumed the given result is true for n is equal to k. So just substitute n is equal to k. So I have written ai plus ba whole power k is equal to a power ki plus k into a power k minus 1 ba. Now let us prove the result is true for n is equal to k plus 1. ai plus ba whole power k plus 1, that is equal to a power n into I. So a power k plus 1 into I plus n, in the place of n, k plus 1, a power k plus 1 minus 1 into b into a. So on simplification what happens? A power k plus 1 I plus k plus 1 a power plus 1 minus 1 will become 0. So k plus 0, that is k a power k b a. So now let me take our LHS. By solving the LHS, let me show that is equal to RHS. AI plus BA whole power k plus 1 equal to AI plus BA whole power k into AI plus BA power n. A power k plus 1 can be written as a power k into a. The power m plus n can be written as a power m into a power n. So that is what we have done here. We have assumed that the result ai plus ba whole power k, that is the result is true for n is equal to k. So substitute that a power ki plus ka power k minus 1 ba and keep this as it is. Now multiply these two things, a power ki into ai. So a power k into I into I will be again I, identity matrix, a power k into a power 1. So a power k plus 1. So a power k plus 1 into I. The next term a power ki into ba. A power ki into ba. The first term with the two terms we have done. Now the second term I am taking k a power k minus 1 ba into a into I. So k a power k minus 1 a power 1. So a power k minus 1 plus 1. B as it is, A as it is, and I. So the next step is this element with the second element. K A power K minus 1 BA into BA. K A power K minus 1 into BA into BA. That is what they have written. So the next step, A power K plus 1 into I plus A power K I BA plus K A power, this minus 1 plus 1 will become 0. So A power K I BA plus K A power K minus 1 B into B, B square. A into A will have A square. So what is the value of A square we have to find with the help of the matrix they have given. A square matrix is A into A. So 0, 1, 0, 0, 0, 1, 0, 0. So on multiplication what we will be getting? 0 into 0 plus 1 into 0. Next, first row, second column, 0 into 1 plus 1 into 0. Next, second row, first column, 0 into 0 plus 0 into 0. Next, second row, second column, 0 into 1 plus 0 into 0. So we got everything 0. So A square equal to 0. So just substitute A square equal to 0 in this term. So if I substitute A square is equal to 0 in this term, the whole term will become 0. So now we are left out with the three terms, A power K plus 1 I plus A power K I BA plus K A power K I BA. Next, from the second term and the third term, A power K I BA is common. So let me take it out. So 1 plus the left out thing is K. So A power K I BA into 1 plus K. I is identity matrix, A is a given matrix, so A into I is again A. So A power K plus 1 I plus A power K B, I into A I have written A into K plus 1. So this is what our RHS is. So we have proved the result is true for n is equal to K plus 1. Therefore, the result is true for all the values of n. We have proved this by mathematical induction, principle of mathematical induction. The next problem, A is equal to 3 by 3 matrix is given and they asked us to prove A power n is equal to 3 power n minus 1. So this matrix for n belongs to n. So this is again a mathematical induction because they have asked us to do this for power n. So we cannot do it go on multiplying A into A square, A cube. So that is why we are doing this by using the principle of mathematical induction. So A power n matrix is given. The first step is we have to prove this result is true for n is equal to 1. So to prove this is n is equal to 1, A power 1 is equal to 3 power 1 minus 1. What is 3 power 1 minus 1? 3 power 0. 3 power 0 is nothing but 1. So A is equal to 1, 1, 1, 1, 1, 1, 1. So the result is true for n is equal to 1. Why it is? Because this is what the given matrix in the equation. So the next step is we are going to assume the result is true for n is equal to k. So A power k is equal to 3 power k minus 1 in all the places. So next thing we have to prove A power k plus 1. So A power k plus 1 is equal to 3 power k plus 1 minus 1. So k plus 1 minus 1 is 0. So 3 power k. I got it. A power k plus 1 is equal to 3 power k all the way. I am going to prove this result now. So take the LHS and prove your RHS. So let me take A power k plus 1. A power k plus 1 can be written as A power k into A. Since we have assumed the result is true for A power k, we know what is A power k. So 3 power k minus 1 and A is the matrix the given in the equation 1 1 1 1. So multiply these two matrices. On multiplying these two matrices, what will be getting? 3 power k minus 1 into 1. 3 power k minus 1 into 1 plus again 3 power k minus 1 into 1 plus 3 power k minus 1 into 1 power k minus 1 into 1 plus 3 power k minus 1 into 1 plus 3 power k minus 1 into 1. So this is the element of the matrices throughout. So how many times we have this 3 power k minus 1? 3 times. So 3 times of 3 power k minus 1. Here the power is 1. So now this can be written as 3 power k minus 1 plus 1. So 3 power k. So 3 into 3 power k minus 1. Next 3 power 1, 3 power k minus 1. So what happens? 3 power k minus 1 plus 1. So minus 1 plus 1 will become 0. So 3 power k. So 3 power k, 3 power k, 3 power k in all the places of the given matrix. We have taken LHS and we have proved it is RHS. Therefore the result is true for n is equal to k plus 1. Therefore the given statement is true for all the values of n. The next problem, they have given A matrix. A is equal to 3 minus 4, 1 minus 1. Then they asked us to prove the result. So they have given it as power n. So this will be proved by using the mathematical induction. Let us follow the principle of mathematical induction for this problem also. Because we cannot go on repeating the matrix n times. That is why we are doing this by using principle of mathematical induction. Our first step is to prove the result is true for n is equal to 1. So just substitute in the place of n 1. So on substituting in the matrix A per k, n is equal to 1 plus 2n minus 4n, n 1 minus 2n. I will substitute A per 1 is equal to, what happens? 1 plus 2 minus 4, 1 minus 2 is, okay. So our A per 1, A matrix is 3 minus 4, 1 minus 1. This is what our A matrix given in the question. So we have proved the result is true for n is equal to 1. Now let me assume this result is true for n is equal to k. A per k is equal to 1 plus 2k minus 4k, k 1 minus 2k. Now we are going to prove the result is true for n is equal to k plus 1. So A per k plus 1 is nothing but 1 plus 2 into k plus 1 minus 4 into k plus 1, k plus 1, 1 minus 2 into k plus 1. On simplification 1 plus 2k plus 2 minus 4k minus 4, k plus 1, 1 minus 2k minus 2. So we got it like 3 plus 2k minus 4k minus 4, k plus 1 minus 2k minus 1. How will you prove this result is true for n is equal to k plus 1? Let me take the LHS and show this RHS. If those two things are equal, then we can say the result is true for n is equal to k plus 1. Take LHS A per k plus 1. A per k plus 1 can be written as A per k into A. A per k matrix we know that, and A matrix we have on multiplying it 3 into 1 plus 2k minus 4k into 1. Next 1 plus 2k into minus 4 plus minus 4k into minus 1. The next element k into 3k, 1 minus 2k into 1. The next element is k into minus 4 plus 1 minus 2k into minus 1. Now simplify this. 3 plus 6k minus 4k minus 4 minus 8k minus into minus plus 4k, 3k plus 1 minus 2k minus 4k minus here, so minus 1 plus 2k. So now simplify this. 6k minus 4k plus 2k, so 3 plus 2k minus 4, minus 8k plus 4k, so minus 4k, minus 4k, minus 4. 3k minus 2k, k plus 1. Minus 4k plus 2k minus 2k minus 1. Therefore, we have proved it RHS. Hence, the result is true for n is equal to k plus 1. Therefore, the result is true for all the values of n. The next problem. If A and B are square matrices of the same order such that they have given AB is equal to BA. Okay, now we have to prove by induction that AB the whole power n is equal to B power n into A. This is one of the result. Further prove that AB the whole power n is equal to A power n, B power n with the result AB is equal to BA for all n belongs to n. So first let us prove this result by using mathematical induction. AB power n is equal to B power n into A. So substitute n is equal to 1, AB is equal to B power 1 into A. So AB is equal to BA. This result is given in the equation. So therefore it is true. Therefore the result is true for n is equal to 1. Now let us assume the result is true for n is equal to k. That is A B power k is equal to B power k into A. That is what they have assumed it. Now we have to prove this result is true for n is equal to k plus 1. What is n is equal to k plus 1? A into B power k plus 1 is equal to B power k plus 1 into A. Now let me take the LHS and prove the RHS. A B power k plus 1 is equal to A into B power k into B. Next step, A into B power k. What is our A into B power k is? A into B power k is B power k into A. So I'll write it B power k in A, B. The next thing AB. What is our AB? In the question they have given, it is BA. So B power k, BA. B power k, B power 1, so B power k plus 1 into A. Now I have proved my RHS. So LHS equal to RHS. Hence the result is true for n is equal to k plus 1. Therefore the result is true for all the values of n. The next part of this question is A, B the whole power n. A, B the whole power n is equal to A power n, B power n. We have to prove. First we have to prove this for n is equal to 1. So substitute n is equal to 1. A, B whole power n. A power 1, B power 1. That is A into B. A, B is equal to A, B. It is obvious. Therefore the result is true for n is equal to 1. Now let us assume the result is true for n is equal to k. A, B power k is equal to A power k, B power k. Now let us prove this result is true for n is equal to k plus 1. A, B whole power k plus 1 is equal to A power k plus 1 into B power k plus 1. This is what we have to prove. Let us take the LHS side. Our LHS is A, B the whole power k plus 1. Let us write this as AB whole power k into AB. Now A power k, B power k into AB. Because we have assumed the result is true for k values. The next step is, here we have B power k into A. B power k into A is nothing but A into B power k. Why? Because in the previous result we have proved A B power n is equal to B power n into A. So that I am applying here A into B power k. Now this I can write it as A power k plus 1 into B power k plus 1. The result is true for n is equal to k plus 1. Therefore the result is true for all the values of n. So the second part of this question is connected with the first part of the question. So with the help of the first result only we can able to prove this result.